Well, hi, good morning, and thanks for joining me. Now, before I go any further, I just want to warn you I've done some time traveling in this video, and I'm here from the future right now. The fact is, the radio that this video relates to is fixed, and it's been out of my shop for a week, and I'm only now posting the videos. So, the last video that I posted was basically a video of me getting quite confused about how the radio was wired and not believing what I was seeing, which I think was a bit of a disappointing video for some of you. It's pretty disappointing for me too. But I carried on and I finished off the radio without ever understanding what it was I was seeing with the wiring of the rectifier. Yesterday I posted that video and someone was kind enough to send me the correct schematic. So I want to take a look at it with you before I show you the last video on this same radio, which I actually did a week ago. So let's take a look at the schematic here. Okay, so like a lot of schematics, this covers a couple of different versions of this radio, but this is the correct radio. Now, I myself did dig up some Sylvania schematics of similar Sylvania radios, but I never found one that had the kind of wiring in the power supply that would explain what I saw, which was a direct connection between the heater pin and the plate pin on the rectifier tube, which I just have never seen that before. So voila, here's the correct schematic. I mentioned it's for a couple of different variants in the radio, a couple of different chassis. This one's got the clock, this one does not have the clock. So in fact, this is the guy, and without getting into too much confusion here, this is the power supply minus a couple of features that are on other models. So for instance, this schematic is showing a appliance outlet on the back of the radio. Well, there is none on the radio I have. So we just know it can't be those models. So I don't have that. If you look at this version of the power supply, there's a light bulb. Well, my radio doesn't have that. Okay, and then there's this very curious thing here called a panelescent control. So I can only guess that this is, in some cases, the panel had some kind of lighting feature in it, not an ordinary light bulb, something else going on that somehow lit the panel. I don't know what this is, but it's got a variable control here. I don't know what that is. Doesn't exist on the radio I have. The radio I have has the plug, the clock, and the rectifier tube, and this automatic switch. I skipped that, the automatic switch, which was broken on the radio I had, but I was intent on replacing this with a manual switch on the back of the radio. So okay, so what's going on here then? Let's take a look. So here's the heater string for the tubes in the radio, and of course this is the rectifier tube, and there's all the same pin numbers I was gawking at. Pin 3, pin 4, pin 6, and there they are wired just as I saw them. Look, pin 4 is connected to the plate of the tube. So it is exactly as I saw it. The incoming 120 volts, this is one line, this B minus line if you like. The other line's here, and look. Okay, so 120 volts is put across from here to here. It's just something I've never seen on another radio. I've always seen the power going in here. Now, maybe I've seen some of these and not really spotted what was going on. So the question comes now, well, what is going on? Why would the engineers design it like this rather odd arrangement? And I don't have a good answer for that. Perhaps someone has commented on the last video already on why this might be done this way. But it looks to me like this part of the filament then is carrying the plate current. I guess it's possible there's enough current through the rectifier tube to heat this side up. It just seems like a very weird arrangement to me. Or perhaps this serves the purpose of a resistor in the plate circuit, and somebody cleverly figured this all out. I don't know. Now you've got a full line voltage dropping on less heaters than these are really intended for. You've got too much voltage on this part of the heater, as I measured it, around 20 something volts across here. I really don't know. I don't know. It's maybe one of you knows and can explain it in some detail why this was done. My guess is it's just a low-cost solution to making the radio work. So there we go. There it is. It's all for real. You've probably heard far too much about this now, so I'll just get on with showing you the video I shot 5-6 days ago. Well, I'm really paralyzed here. I looked for a schematic. Hey, good idea. Look for a schematic. Couldn't find one for this radio, but I found one for a different Sylvania radio, but it looks almost the same. The only difference here on the cabinet is it has 3 controls at the top here, nothing here. But the cabinet is the same shape. And so when I look at the schematic for that radio, it also has the same tube complement. It has a light bulb. Okay, so the light bulb in radios like this utilize the center tap on the heater. That's why the heater has a center tap, to provide an opportunity to cheat a voltage out, basically to run a panel light. Okay, it might have a few other side benefits, but the main purpose, like I think I've heard it, that the light is there to protect the filament. It may have that effect, but really the center tap filament is there to provide for the light. That's my understanding of it. And even that doesn't make a lot of sense to me. But anyway, I won't go into that. This one has no light, so this one's a schematic. Had I had it, it would be a little different than the one I'm looking at. The one I'm looking at, this is done wrong. The 2 pins that are soldered together are the wrong pins. But you know, I just can't accept that. Oh, they blew it. They made this radio wrong. Especially soldering these pins together. It's just not. It's not making any sense to me. So I'm gonna stop for now. I got other stuff to do today anyway. Look at that. It's almost 4 o'clock in the afternoon. I'll let this sit for a while. Maybe I can. You know, I've looked this radio over and over, by the way, for the model of this radio. I cannot find it. The model of the radio that I'm comparing it to is model 5484. 5484. Looks like the radio was made by a number of other, or under a number of other brand names also, other than Sylvania. There we go. I don't know. I'm not about to change this to the way I think it should be. That's probably suicidal. That's it. I'm stuck. Okay, just a thought. When I got this radio, it came with this 35W4 with the bottom busted. I said something about you know, these tubes can take some brutality from heat. Could this thing actually be miswired? And overheating half the heater in here, it's enough to make the radio work, but it burned the tube out. Well, caused the base to crack. Is that the story? So the 35W4 I've got in there is now being beat up, and potentially it's going to end up this way, or it's going to get an open circuit in the heater. I don't know. Well, hi, and thanks for joining me in my shop here. I'm going to be continuing on with this radio, focused on changing out these old wax capacitors, and that's going to buy me some time to consider the weird, what I think is weird anyway. I suppose it's not really weird. Maybe it's me who's weird. The weird way this rectifier tube is wired in here, as I discovered at the end of the last video. So I will ponder that situation while I work on these capacitors. Now the first one I'm going to do is this guy here. Now this one is connected between the line. Here's the incoming line wire here. It comes over to this terminal. Then from here the capacitor goes down to the chassis. This is the single connection to the chassis in this radio. And if this capacitor were to develop a short inside, then the chassis would be just solidly live connected back to the back to one of these terminals, and this whole chassis and a few screws I showed you that protrude from the radio would be dangerous. If they don't put this capacitor in at all, then you have this big floating chunk of metal here, not connected, even though all these parts are inside, electrically not connected to any of these parts. And this thing becomes a big, wild, out of control antenna. And in this piece of metal then will be voltages, not only coming from radio stations, but actually coming from the radio itself. Various oscillations and whatnot can be fed back through this. This just becomes a wild thing to put a radio in. So to settle it down, you want to connect this to the basically the B minus line, but you don't want to do it with a solid wire, or it's going to be electrocution time. So you stick a capacitor in here. That's the happy solution that allows the radio frequency stuff to find its way from the chassis back to the B minus line and be nullified that way. And at the same time, you maintain a certain amount of isolation in case somebody like me should put my hand on the chassis and then grab the local faucet or something of that sort. So this capacitor plays an unusual and a very special role. It has an element of safety related to the radio. So if this guy shorts out inside, the radio becomes very dangerous. So that's why I'm going to put in this kind of capacitor. This is called a type Y capacitor. You see it's constructed a little differently, at least it looks different. It's a 0.05, it's the same size. There's a Y and there's an X that you use in these kinds of situations involving the power line. The Y type that I'm using is designed for this chassis type connection. I'll leave enough tail on here so we can test these capacitors afterwards. This one actually looks pretty good. Duranite, made in USA. Parts come from all over the place in this radio. So this Y-type capacitor is designed so should it fail, and I don't really understand how they can do this, should it fail, it will fail open circuit. That would make your radio noisy, potentially, because you're no longer draining off the interfering signals from the chassis. But at least it wouldn't make the chassis live at 120 volts. But this chassis being live thing, I mean, you really got to read up on it. I'm not going to try to explain it. But it depends which way you plug this plug in conjunction with whether the radio is on or off. And then that, in a little deeper sense, has to do with exactly how the designers have designed the radio. So rather than try to solder to this large thing, I'm going to try to solder to the piece of wire there that's hanging out of there. I'm going to try it. That looks pretty good. Not quite okay. Yeah, did I finish my discussion? I don't think I did. So the white type fails open circuit. The other type, the X type, they look pretty much the same. as this capacitor. The X-type are intended to be put in circumstances where they are across the power line. I just read this, and I've read a few things about these capacitors. I've never read this, what I'm about to say, so as usual, take everything I say with a grain of salt. Okay, the X-type are designed to fail short. They're designed, if they fail, they will develop an internal short. A solid short, solid enough to carry a fault current from the fuse panel, basically from your power line, of a sufficient fault current that your breaker or your fuse should operate in your house. And the result of that, of course, is the power goes out, and it's not long before you figure out it's turning on the radio that's doing it. This then forces attention onto this X-type capacitor. I guess you would have to get your radio fixed or lay it aside at that point. So the whole thing about it failing sufficiently shorted to draw a heavy current and sustain a heavy current, because it's a fault right on your house wiring. Even though you have a 15 amp fuse in your fuse panel, the amount of power that flows through the fault while it's there is way beyond 15 amps. It's basically limited by the transformer that's feeding your house and the wires and a few other things. It can be 100 amps. It could be a lot more in some circumstances too. So if you think the 15 amp fuse or 15 amp breaker keeps the current to 15 amps, no. Not in a fault situation. So a little capacitor here, like a little one of these guys, gets a short and it's installed across the power line. You could picture it kind of blowing apart, or worse yet, not drawing so much power that it sits there and cooks. It looks like an ordinary load to your fuse panel. Remember, you can plug in a toaster, right, and burn bread. Your fuse panel doesn't get upset about it. You can plug in a bad capacitor and cook your radio. The fuse panel may not get upset about it at all. You don't want that. You don't want things catching fire in your radio. So the X-type, which is right across the power line, can take a power line fault, should cause a protection, your house protection, to operate. That's what I read. I read up on these capacitors a couple of times. I've never read that. I've just read the X. This is the way you remember it. The X crosses, where's the camera here? Here it is. The X crosses the line. That's how you remember it. And the Y one, you don't put it across the line. That, again, grain of salt, please. Don't believe everything you hear. Okay, so this guy really looks good, but he's gonna go. He's got to go. So it's going on this big ground terminal, and then down. I'm going to leave a lot of wire here. This gigantic terminal. I'm going to nip it off right on the edge there. This is a beautiful looking, it's another 0.05 capacitor. Wow, now if this doesn't test good in the end, I'll be floored. I've taken out some pretty ratty looking capacitors and they've turned out to be pretty good. Did I say 0.05? I did say that, didn't I? 0.05. There we are. Same terminal. Okay, I'm going to go with the same terminal, do you? Should have noticed that. I've done them both together. So I guess the idea with an ordinary capacitor is if it fails, it may fail open circuit. It may, and that's usually the lead separating from the guts inside the capacitor. You can imagine it's tricky to make this pretty heavy wire here somehow connect to the little sheets of, that I imagine are in here, little sheets of aluminum foil or something like that. And that's usually where the failures occur. You have all that material from the two terminals of the capacitor, all the I'm using my left hand here on this tool. I'm not so good with it. It would be easy for all that material in such close proximity to develop a short circuit. Probably happens again at the terminal point. So you get open circuit or short circuit in one of these. I've seen both those. And I'm going to solder this. This is just too flimsy here. Let's give it a right hand ply. That was apply. 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 Pliers. Appliers. I don't know. Do you use your pliers to ply things? Apparently I heard that every word in the English language that we use today started out as some kind of slang term, almost always with a completely different meaning from what the word has today. So we have these, we have these words, been in a dictionary for 100 years, and we think that's the quote right word. Somehow it got in there through some official channel. Official word committee or somebody. But apparently, it's probably true of every language. Words start kind of spontaneously and get used by the population. But at the time they become standardized words, their meaning has changed. Isn't that kind of weird? And the examples I read were really shocking. Like, I'm just making this one up, but it would be like cabinet. So, well, a cabinet today is a shelf, a storage thing. They might find out that 600 years ago, when the word first appeared being used, it meant dog feces. I mean, it can be like that. So, why did I get onto this topic? Because I'm just trying to keep words pouring out of my mouth while I solder stuff. That's dangerous. Who knows what I might say. And on that note, a couple of videos ago I mentioned how I find it almost unnerving to realize I really don't know what I'm going to be saying 10 seconds down the road. Conversationally, as I'm standing here talking with people, and I'm sure you are actually no different than me. But we're totally comfortable in normal life, talking away, really not knowing what we're going to be saying, and literally having no idea what words we'll use. Just 10 seconds down the road. It's happening to me right now as I talk to you. I really have no clue what is going to come out of my mouth. I just have this faith that it's going to make some kind of sense and not embarrass me, I guess. Okay, so that's 2 done. And we'll go after this one back here. Kind of buried in there. Let's unbury it. It's a little, I was going to say misshapen, but it's really not. Let's see. TOC 0.05 again. This one's really gooey. Made in England. Made in USA. Made in England. Why, it's just odd to me that a radio would have two, you know, what are they putting in their warehouse at the manufacturing plant? 0.05 again. Luckily, I got a pretty good stock of 0.05s. Put it right back in where it came from. No, I'm quiet. I'm thinking, no, Jim, careful. I don't know what's coming out of your mouth. And one of the experiences I have in doing these videos is I get to, when I'm editing them or preparing them, you know, I don't do much editing, but I do have to prepare them, and it involves a little bit of listening and watching. Occasionally I get caught up and I watch my entire video. Can you believe it? I get caught up in my own video. But what I notice, and I've mentioned this a number of times, and this is a big warning to all of you who are viewing these videos, because they're not edited, I don't go back and correct them. I misspeak a lot. Maybe not any more than anybody else, because most of the time when we're watching productions, when people misspeak, it's corrected. So we don't, and when you do it, say you're talking with somebody and you misspeak, you don't really realize you've done it unless the other person goes, "Oh, you meant blue, didn't you?" Then usually you can kind of quickly track back in your memory and go, yeah, blue. Oh, I said red. Why did I say red? What was in your head was blue for sure. And if somebody had stopped you and said, "What did you just say?" you would probably say, "I said blue," even if you said red. And I've had this experience, like on these videos, over and over and over again. It just gives me the chills. I'll say, current when I mean to say voltage. The only reassuring thing about this is when I watch a live news on TV, I see that TV broadcasters do exactly the same thing. They will clearly misspeak, but if you watch them, they obviously are completely unaware that they've misspoken. And I know from my own experience, in their head, they said what they meant to say. Out of their mouths came something else. And this is a tough lesson, because people are generally made uncomfortable in their humanity. That's one of the things we're taught in school. And all those ordinary human things that happen to us, we gotta get on top of those. We gotta get in control of that. We don't want the truth to come out. We don't want the other animals on this planet to realize that we're really not that special. We're trying to keep it secret from all the other animals. I was watching a little piece on artificial intelligence, and there's controversy around what artificial intelligence will bring to the human race. Will it be all positive, or will there be some pretty scary bad stuff? And of course, a lot of people are really boosting the bad stuff. Okay, I've got one more to do, just down the way here. Oh, let me trim this up. So, now why did I bring up artificial intelligence? Because I don't have any. Oh yeah, I remember. So they're going on and on about this discussion about artificial intelligence, and you know, is it going to take over? Is it already taken over? Because artificial intelligence things are happening all over the place at this point in time. No regulation, no control. You know what? I can leave that. It's all good. It's all good. So what will happen to the world when artificial intelligence showed up? And I suddenly asked myself, what has happened to the world since we showed up? People, maybe not that much more intelligent than many other animals, but we have these things here. Okay, and a few other accoutrements that really boost our powers. So if we think of ourselves as compared to all the other living things on this planet, we certainly do stand out. There's no doubt about that. Are we really the first artificial intelligence to show up on this planet? It's just not artificial. We just take that word away. Just say intelligence. We're the first intelligence. Super intelligence. Super capable intelligence. Now ask yourself, how's that gone? Anyway, ask me this. What capacitor did I just take out? I just took this one out. 0.022. 0.022. 0.022. So if we look at it that way, and we think of ourselves as being an example of, why is there, it's much shorter. There's a lot more lead length here. Yeah, that's the broken terminal strip there. Well, you know, everyone's worried that the see, I can make it long this way, or I can make it long this way. I make it long this way. This is going to the output transformer. Or stick it right in the middle. Let's stick it here. We'll make it long this way. I'll find a little bit of a shrink sleeve here. This lead dressing. So I was left kind of chuckling to myself that, hey, they're talking about the horrible things that super intelligence may bring to the planet. Well, just open your eyes and look at what we have brought. Now, it's not all bad. I'm not falling into that trap that so many people seem to be in these days, where they say the world is, you know, going to hell in a handbasket. The world has just gone crazy. The world is wild. Well, you know, it isn't. It just isn't. What has happened in the world, and we should all be rejoicing this, is the amount of poverty in the world has gone way, way, way down. You know, and humanity is being quite successful at improving its lot. It's always worked at that, and it's been very successful the last 20, 30 years. Billions of people taken out of starvation type conditions. All kinds of healthcare improvements, just all kinds of stuff. I mean, look at what you are doing right now. You are using a computer on the internet to watch me do this stuff, using little cameras that I can buy and stick in my home. I mean, there's all kinds of things that are really fantastic today compared to how they were. Yet people tend to think the world is really messed up. Well, some parts of the world are messed up, but far better than it was in the past. So we should really be very happy people everywhere, and we should also be excited about the future. A lot of people have been made to feel pensive about the future, that they've been told something wrong is going on in the world. They're actually being told that the progression of the world is the problem, and we need to stop the progression. And I think these voices have been around forever, either out of fear of the unknown or fear of what they've been told is coming, or something terrible is coming, or things are pretty good today. Let's not disturb the situation because I'm doing okay. So if you're not, well, I'm doing okay. So let's just leave everything as it is. Not good strategies for humanity. Hey, how about this? There is only one race of human beings on the planet. We are all the same race. When people talk about, which means our biology is essentially the same for all of us. It's a little different here and there, but just on the fringes. When human beings have a discussion about race, they're usually talking about small differences in physical attributes, because people have lived in different places on the planet for thousands of years, and they look a little different, but inside we're all the same, all of us. That's going to be a little too long. There's only one race of human beings. So if you think the fight between the Hutus and the I'm going to get these wrong, so I better not use it. Maybe that's the right. This didn't solder here. That the primary difference between two elements of a population is the look of their faces, size of their nose, and stuff like that. And we laugh at that. Go, really? That's how you're dividing a population? Based on facial look? If you don't know what I'm talking about, I'm not going to go into it. But if you looked up, I think, Hutu, and there's another population in this country, you look that stuff up, you'll find all about it. That's all it is. Just a difference in how people look. Meaningless. Tell you something else I did the other day. I watched this video of New York City in 1900. And it's just film. It's a pretty nice film, like good quality film for 1900. Of the streets of New York. I guess right downtown. I don't know where exactly, but big buildings and stuff. And you just see the people walking around on the streets and doing their thing and stuff like that. Don't get me wrong when I say this next thing. Every one of them looked like a recent immigrant. I don't mean that in any kind of pejorative way or anything like that. It's just that's the reality of people arrived in the United States. They arrived, I think, outside New York. Often took up residence in New York City. It's probably why New York City got to be so big. And I mean, you can tell they're recent immigrants. I would suggest, I was gonna suggest something, but I won't. I won't because I'm talking too much here. Okay, so I'm just about finished this anyway. See that? Just the struggle of man. I don't know if I can pinch that. I watched another video yesterday that really blew me away, and it was on the population of the world, the population explosion. It's a guy from Sweden, a statistician from Sweden, starts out by saying population of the world will never get larger than 11 billion. I think it's 7 now. Well, say, why is that? It's not for any kind of weird reasons. He shows in his video exactly why that's going to happen. And the world's population will rise, human population rise to 11 billion and probably not go beyond it. Or, you know, just a small amount, not obviously that's not a precise number. And he says, look, you all heard of say geometric, is that the right word? Maybe not. Geometric rise of the population? I don't think that's the right word. I can't get the right word in my head. You know, the curving rise, the ever increasing rate of population increase in the world. And he blew me away. He goes, well, that's not happening. That happened. That's over. The world's population is now increasing linearly. And again, he showed statistics and stuff like that. Yeah. For the last, I don't know how long, 10 years, 5 years, just linear increases in population. And he explains why that is and why it's going to continue that way. And eventually it will, up around 10 billion, it will start to turn down and eventually flatten out around 11. And that'll be it for people. It has to do with birth rate and things like that. Quite a different picture from what I've been hearing all my life, which is population explosion, the world is flooded with human beings, destruction is nigh. Okay, I think we should probably give this guy another try just to make sure it's still working. Everything I'm not thinking of here. There still is the the cathode resistor here, which is says 50 on the color code, about 175 I think it was on my ohm meter. We'll leave that one for now, because I think the worst it can do is slow down the output tube a little bit, even though the output tube bias is supposed to be minus 7 volts and it's only minus 1.5. So that none of that's adding up very well. Let's just see if changing a few capacitors help that situation out. Now, of course, because I've fiddled mightily with the radio, especially that first capacitor, I do this as a matter of routine anyway. A little higher, please. Thank you. I want to engage these light bulbs when I first turn this radio on. Volume's down. Turn it up just a wee bit. Okay. Switch down. So you watch this meter. Watch those lights. This meter should come up, go back, and then come up, something like that. Come up, and stay up. The come up, go back thing happened so fast you couldn't even see it. Okay, so everything's fine. Tubes are lighting up. Let's just wait till we hear something here. There she comes. What are we waiting for? We're waiting for full power. Let's tune around a little bit. Let's see. Don't touch those together. Okay, my little neon light is not coming on. Switching the plug around. Can't imagine that can make any difference here. Nope, can't get my little light to come on. Scary. Scary for me. Like I say, I did get a heck of a lift off one of these things once. Why don't we put the voltmeter on it just to be even more. So the neon light, anything over 60, 70 volts should light the light. Zero. Okay, just ignore everything I was saying, I guess. Tuning time. Just in case this switch decided to work. Oh, how can it work? We saw it's busted. Okay. I can't turn it off, can I? That's the whole problem, Jim. You can't turn it off. Okay, now we're forced to deal with this bizarre situation here. It's probably not bizarre. So I do want to install another switch on the back and interrupt the power to the radio without interrupting the power to the clock.